I'm Anil Kumar. Welcome to my series on linear systems. Here is a test paper on this unit. We have 10 questions. Let's go through these questions and then I'll provide you with complete solution. You can actually in between pause the video, solve some of them and then look into my solutions. Question number 1 is to solve by graphing. Question number 2 is to solve by substitution. Question 3 is to solve by elimination method. In question number 4, you can solve the equations using any method of your choice. Same is the case with question number 5. Now in question number 5, we have involved some fractions. Question number 6, 7, 8, 9, and 10 are the word problems. So you need to define variables. Always use two variables for linear systems. Write down your equations, solve them using method of your choice. Correct? So let's begin with solution of question number 1, which is solved by graphing. Now we are given two equations here, 3x minus y equals to 6. So let's rewrite this. We have 3x minus y equals to 6. The other one is y equals to 2x minus 5. And we have y equals to 2x minus 5. We have to solve by graphing. So to sketch the graph, let me isolate y and write them in slope-intercept form. So I could write this as y equals to 3x minus 6, right? And here we have y equals to 2x minus 5. So I don't have a graph paper at present, so I'll just sketch one here. Remember, graphing solutions are not very accurate, right? So, and normally the questions provided will give you integer values so that you can, provide correct solution. So let me just make a graph here for you and then we will sketch and find solution, right? So since we have the equations with y-intercepts as minus 6 and minus 5, lower half more, right? So I'll focus more on this lower half portion. And both these lines have positive slopes. So I guess they will be rising lines. So we expect somewhere here. So I'm partially sketching, making my graph here. So I have to go at least 6 units down since we have minus 6, right? So 1, 2, 3, 4, 5, 6. Let me draw one more. Okay. So let us say this is our graph paper, okay? So I'm going to sketch the first line, which is y equals to 3x minus 6. That really means that the y-intercept is minus 6. So you go 6 units down, 1, 2, 3, 4, 5, 6. That is your starting. Slope of 3 means rise over run. So 1, 2, 3, and 1. So that is your point. Again, you do 1, 2, 3, and 1, right? So that is how we are going to sketch this particular line. Okay, so connecting these points, we get our first line, which is kind of like this, okay. Now let's sketch the second line, which is y equals to 2x minus 5. So 2 is the slope, y-intercept of minus 5. So minus 5 is right there. 2 means rise of 2, run of 1. 1, 2, and run of 1. So we get the same point here. So fortunately, we have a solution, right? 2 and 1, we get this point. 2 and 1, we get that point. Joining these points, we get our lines. We could draw this line as like this. Is that clear to you? Point of intersection is the solution. Perfect. So that is the solution for us, which is at 1, the value is 1, 2, 3, minus 3. Correct? So from the graph, right, we get solution is basically intersection of lines, right, which is the point, let's call it P, and the coordinates of these points, this point is 1 minus 3, correct? So that is how you get your solution. So I hope it is. Now let us solve question number 2, which is solved by substitution. 5x minus 2y equals to 26 and x plus 7y equals to 20. You can isolate x from here, substitute in the first equation and find the values. So the two equations are 5x minus 2y equals to 26. Let's call this as our equation number 1. The second equation is x plus 7y equals to 20. So that's the given second equation. Now from the second equation we can isolate x, which could be written as 20 minus 7y, right? So that's our equation number 3. Now let us substitute the value of x from 3 in equation 1, right? So we get 5 times the value of x is 20 minus 7y, and we have then minus 2y equals to 26. Open the bracket, so we get 100 minus 35y minus 2y equals to 26. So that gives you 100 minus 37y, right, equals to 26. Bring 26 to the left side, so we get 100 minus 26 equals to 37y, right? So this is 74, and we can now divide 74 by 37 to get the value of y, which is 2 times, right? So 2. So we get y equals to 2. Let's call this as our equation number 4, correct? Now let's find the value of x by substituting the value of y in our first equation, rather third equation, right? So we know y equals to 2. We'll sub this in equation 3, right? Which is x equals to 20 minus 7y. So x will be equal to 20 minus 7 times 2. So x is equal to 20 minus 14. So the value of x is 6. So our answer is the coordinate point 6 and y value of 2. Is that clear to you? Perfect. Now let's move on and solve question number 3. Solve by elimination, and the two equations are 6x plus 3y plus 6 equals to 0 and 4x minus 5y equals to 38. So let's rewrite them. We have 6x plus 3y. Now let's write 6 on the other side. So we'll write minus 6 here. The second one is 4x minus 5y equals to 38. So that is equation 1, this is equation 2. These are given to us. To eliminate, we have to get same value of x. What we can do here is, since these are all multiples of 3, so one step, let's divide all of them by 3, right? So if we divide by 3, we could simplify this further, getting this equation as 2x plus y equals to minus 2, right? So we divided everything by 3 for the first equation. So here what we did was, equation number 1 divided by 3 gave us this. Now to get 4, we can multiply this by 4, right? So now we will do, let's call this as our equation number 3. Okay, so now we'll multiply equation number 3 by 2, right? So same equation we are multiplying by 2, so that gives us 4x plus 2y equals to minus 4. Clear? So what you see here is that the coefficients of x are same in equation 2, and we'll call this as our equation 4. So what we can do is we can take one from the other. So we'll do equation 4 minus equation 2. Correct? So when you take away 4x minus 4x is 0, 2y minus 5y gives you 7y equals 2. Here we have minus 4 minus 38. Correct? So we get 7y equals to minus, that is 42. Or y is equal to minus 42 divided by 7. So we get y equals to minus 6. Right? So we got y equals to minus 6. Now we can substitute the value of y in any one of our equations. So let's call this as our equation 5. So whichever you want to prefer. So I'll actually substitute in equation 3, right? So what I'm going to do now is, so let me just draw it like this. Okay, now we'll sub y equals to minus 6 in our equation number 3. That is simplest equation we have. So we'll write here as 2x plus the value is minus 6 for y equals to minus 2. So we have 2x equals 2. Taking it to this side, it becomes plus 6, right? Or we could write this as 4. So x is equal to 4 over 2, which is equals to 2. So our answer is the x value is 2 and the y value is minus 6. Is that clear? Right? So now what you could do is, question 3b for you is to check this solution. Right? So you can substitute this back into the equation and see whether it works or not. Does make sense to you? Right? So that is how you could check it. Let's look into the solution of question number 4. Now this time we have given you slightly more complicated equations. Let's see how to work with them. So the first equation is 6x minus y minus 3 equals to 25. Let's simplify this. So we get 6x minus y plus 3 equals to 25. We can say 6x minus y equals to 25 minus 3, or we get 6x minus y equals to 22, right? So that's the first equation we have simplified. The second one for us is 2 times 5x minus 1 plus 3y equals to 16. So open the bracket, 10x minus 2 plus 3y equals to 16. We have 10x plus 3y equals to 16 plus 2. So we get 10x plus 3y equals to 18. Okay, now you can use any method of your choice to get your solution. So what we can do is we can isolate y from here. So we can write y equals to, taking y on this side, 6x minus 22, correct? And we'll substitute here, right? So let's call these equations by some numbers. So we are saying this is our equation 1 and this is equation 3. We'll call this as our equation 2. So now what we will do here is that we'll sub equation 3 in 2, right? So by substitution we'll solve. So we have 10x plus 3 times the y value 6x minus 22 equals to 18. So let's open the bracket. We get 10x plus 18x minus 66 equals to 18. Okay, so that gives us 28x equals to 18 plus 66, right? So which is 28x is equal to 6 and 8, 14, 4, 1, so 84, right? Okay. So let's take it on the other side to solve it further. So we might use calculator now. So what we have here is we had 66 plus 18, which gave us 84. And on the other side, we have 10 plus 18, which is 28. So to get the value of x, we have to divide 84 by 28, correct? So that is how much? So let's divide 84 by 28, and that gives us 3. Okay, so x is 3 for us. So let's call this as our equation number 4. Fortunately, we got a good value. And now we'll sub x equals to 3 in our equation number 3, which gives you the y value. Is that okay? So we have y equals to 6 times x value of 3 minus 22, right? So which is 18 minus 22, which is minus 4. So the solution here will be 3 and minus 4. Is that clear to you? So that becomes our answer. Is that clear? So that is how we are going to solve it. So now we have another question which involves fractions. You can use any method to solve this linear system. So I'd like you to pause the video now, solve, and then look into my solutions. Question number 5. The equations given to us are x over 5. Let's rewrite. X over 5 minus 3y over 2 equals to minus 9 over 5. The other one is x over 3 minus 5y equals to minus 8. So whenever there are fractions involved, we should get rid of fractions, right? So the idea here is to get rid of fractions. So that's the key. So what should you do? So the whole equation which you have to multiply by a common denominator, which is 10 in this case. And here you could multiply everything by 3. Is that okay? So that is how we are going to get rid of fractions. So we get here, when you multiply by 10, you get 2x minus 5 times 3, 15y equals to minus 18, right? And on this side, you get x minus 15y equals to 3 times 8, which is minus 24. Is that clear to you? So we get our new equations. Let's call them equation number 1 and equation number 2. Is that clear? Minus 15y is common, and therefore we can now do equation 1 minus equation 2. So 2x minus x will give you the value of x equals to minus 18, take away minus 24. So that becomes plus 24, right? So the x value will now be 6, right? So 24 minus 18. So we get the value of x. Now, to get the value of y, we may use any one of our equations. So we have this. Let's call this equation as 3. So we'll sub 3, the value of x, in, let us say, question 2, right? In 2. So let's substitute here. So what do we get? So we are substituting the value of x, which is equal to 6 here, right? So we get x equals to 6 here. So we get 6 minus 15y equals to minus 24. So 6 plus 24 is equal to 15y, correct? So 30 is equal to 15y. So 30 divided by 15 is equal to y, which is 2. So we get our answer, which is the x value is 6 and the y value is 2. Is that clear to you? So that is how we are going to find the solution of question number 5. Now we are looking into the word problems. Now there are 4 word problems. Let us see how to solve them one by one. Anil solves a system algebraically with substitution and without making errors. He gets this equation, which is minus 6x plus 6x equals to 5 minus 5. Explain what his answer means. Well, minus 6x plus 6x is 0 and 5 minus 5 is also 0. So 0 equals to 0 is always true, right? So that means what? That means we have infinite solutions of the linear system. Is that clear to you, right? So that means we are dealing with coincident lines, right? So that is how you could explain it. It's kind of like this. Let's say we have one line here and the other line overlaps, right? So the other line overlaps. So they are always intersecting. We have infinite solutions. These lines are coincident. 0 equals to 0 is always true. That is what you will get, right? Question number 7. The difference between two numbers is 7. The sum of the number is 5 less than 3 times the larger number. Find the two numbers. So we have to define two numbers. We say let two numbers be, let's say A and B, right? So one is smaller, one is larger. So we say let A be greater than B, right? So that means A is larger. Now it says difference between two numbers is 7. That means we get the first equation, A minus B is 7, right? So that is our first equation. Second, the sum of the numbers is 5 less than 3 times the largest. Sum is A plus B. Sum of the numbers is 5 less than 3 times the larger. So 3 times the larger number A minus 5. Do you understand now? So I'd like you to read this sentence once again. The sum of the numbers is 5 less than. So when you get less than, 5 comes later. 3 times the larger, right? So we'll call this as our equation 2. So we have two equations you need to solve. Now the best way to solve is you can just add them up, right? So if I add equation 1 with equation 2, I get 2a equals 2. B and B cancel, right? So on this side, we get 7 plus 3a minus 5, correct? So taking 2a to this side, and let me rewrite like this. 2a equals to 7 minus 5 is 2 plus 3a. Is that okay? So now we'll just go to the right side and solve it further. So from here, you could rearrange, right? So we get 3a minus 2a equals 2. So when you add it, we got 2 on this side. We brought 2a to that side. This is minus 2. You get the idea, right? So a equals to minus 2. Now, we'll call this as our equation 3. Substituting 3, which is a equals to minus 2, in, let's say 1, we'll get the value of b, right? So we have minus 2 minus b equals to 7. So minus 2, bringing 7 here, taking b to the other side, minus 9 is b. So our answer here is the two numbers are, so we have a equals to minus 2 and b equals to minus 9. Clearly a is greater, correct? So these are the two numbers. Is that clear to you? Perfect. So let's take the next question now. Question number 8. It took Suzanne 8 hours to row 40 kilometers upstream, so against the flow of the river. The return trip took 5 hours. Find the speed of the current, right? So basically, first think about this question kind of like this. So the stream is flowing in this direction, right? So obviously, when you go against, you take more time. So when you go up, right? So like when you're going upstream, it says Suzanne took 8 hours. So this took 8 hours, and the distance is 40 kilometers. But while coming down, the same thing, it took 5 hours, right? Let me write 5 hours, and the distance still is 40 kilometers, correct? So while coming down, that was the situation. You need to find the speed of the current, right? So you can find speed of both, right? So rowing speed and the current speed, you could find both. So let us see how to solve such questions. So it's a distance, speed, time question. Remember one thing, that how distance, speed and time are related. So distance basically is equal to speed into time, right? So distance is speed into time. That is how they are related. We are going to use this relation to solve the question, correct? Now, let's put this information in the form of a table. So we'll construct a table here, and we'll have distance, speed, time, 3 columns. Okay, 1 for going upstream, 1 for coming downstream, right? So let's say that is the information we are going, right? So we are saying upstream and we are saying downstream. Let's this be the distance, right? Speed and time. So distance for us going up and down is same, which is 40 kilometers. The speed is something which we don't know, but time we know. Time going up is 8 hours and 5 hours to come down. The unit are hours, and this is kilometers. Speed will be kilometers per hour, correct? So we have written unit here. Now let us say that rowing speed is r, right? And the water, let's say rowing speed is r and the water speed is w. So when you're going up, you're going against water, so it'll be r minus w. But when you come down, it'll be rowing plus water, because water and rowing both are in the same direction, right? So we're saying r is rowing speed. So r is rowing speed in still water, right? and W is the water current. So these are our two variables, correct? Now, we can always write this distance, speed into time. So we have one equation which is 40 equals to R minus W times 8, right? Dividing by 8, we get 40 divided by 8 equals to R minus W. So we get R minus W as 5. So we get one equation. Clear? The second equation is with 5, right? So we have 40 equals to R plus W. Time taken is 5. So we can write this as R plus W is 40 divided by 5, which is 8. So we have two equations here, equation number 1 and 2. Correct? So we can actually solve these equations and get our answer. So we have two equations. One is R minus W equals to 5. The other one is R plus W equals to 8. To solve them, it's easy to add. But since we want the water speed, I will just subtract. We want speed of the current. Is it okay? So W. So we'll just subtract. So when I subtract, R and R cancel and we get minus 2 times W equals to minus 3. Correct? So the speed of the water will be minus 3 divided by minus 2, right? Which is 1.5, you can say, right? So the water current is 1.5 units are kilometers per hour. Does it make sense to you? So that is how you can find the solution. So I hope that really helps you to understand. So whenever you have a speed, distance, time related question, which you'll definitely get for linear systems, use these strategies. Distance, speed into time. Write your equation in terms of product, right? Distance is what? That will be better, right? So that is one thing. And then you can solve it. In this case, since these are factors of one another, you could also write R minus W is 40 over 8, R plus W is 40 over 5 and solve. You could do that. So, but in general, I'll prefer you to write distance equals to speed into time and then solve. So I hope the concept is clear. Now let's move on and take the next question. 2 more to go, right? Question number 9. I'd like you to pause the video, read the question, solve, and then look into my suggestions. Question number 9. Peter just completed a 500-kilometer hike that took him 61 hours. He traveled by dog sled at a speed of 20 kilometers per hour. And when the dogs ran away, he traveled by foot at a speed of 4 kilometers per hour. How much time did he spend walking? So again, same strategy we are going to use. We'll make distance, speed, time, 3 columns, right? Okay, and we're traveling by 2 modes. Okay, so we have distance, speed, time. Distance again is in kilometer. Speed will be kilometers per hour. Time is in hours, correct? So these are the units. Now, in this case, it is by dog sled and by foot. 2 ways. And this is kind of total distance, right? So, Peter just completed 500 kilometers. So, that is the total distance. Is that clear to you? That took him 61 hours. Total time is 61 hours. He traveled by dog sled at a speed of 20 kilometers per hour. So this is 20. And when the dogs ran away, he traveled by foot at a speed of 4. How much time did he spend walking? So we need to find this time for walking. Do you understand? That is what we need to figure out. So how could you do this question? So we also want to know how much time did he took on this sled. Total is 61. Is that clear to you? Right? Now, distance is product of these two. So distance will be what? 20d, and this will be 4w. Is that okay? Now clearly you can see that we have 2 different equations, right? One equation relates the distance. sum of these two. The other one relates time, sum of these two, correct? So based on this, we can write two equations. One is 20d plus 4w is equal to 500. Clear? The other one is d plus w is equal to 61. Is that clear to you? Perfect. That is how we should be solving. Now, to use which method, what we could do is we could divide the first equation by 4. 4 is a common factor here, right? So let's get back to this equation here. We'll divide this by 4. So when I divide this by 4, 4 times 5, so we get 5d plus w equals 2. Dividing by 4, 4 times 1, 10, 4 times 2, 125. Clear? Now, we are calling these as our equation number 1, 2, and 3. So you see w is common here, right? So walking time, okay. So what we will do is we'll do elimination. So to eliminate, we'll do 3 minus 2. So when I do 3 minus 2, I actually get 4d dog sled's time. Right, that is the time taken in here. And here I get 125 minus 61. So d is 125 minus 61 divided by 4. Correct? So let's use calculator to figure this out. So we have 125 minus 61 and divide this by 4. So we get 16. So time in the dog sled was 16 hours. So walking time is how much? So walking time is 61 minus 16. Is that okay? So from 61, we'll take away 16 to get 45 hours. Is that clear to you? So we could actually find our answer like this. So we have our answer here, which is spent walking time, walking was equals to 45 hours. Is that clear to you? That is how this will be answered. Perfect. So let's move on and take the last question. Now let's take up the last question, question number 10. Anita is 6 years younger than Sam. 18 years ago, she was 2/3 Sam's age. How old is she now? So again, let's make a table, right? So similar kind of table we'll make. However, now we have different parameters. So we're talking about two persons and at two different times, correct? So one is Anita is 6 years younger than Sam, right? So, well, we can also say like this. Let Anita be A, age, right? SBS, right? So Anita is 6 years younger than Sam means Anita is Sam minus 6. Is it okay? 18 years ago, she was 2/3 Sam's age. So 18 years ago, Anita was A minus 18 and Sam was Sam minus 18, right? But says 18 years ago, she was 2/3 Sam's age. So we get the second equation. Do you see that part? So we get equation number 1, equation number 2. I kind of avoided making table here, but you can look into some of my videos on age where we have solved using the table. Similar method to what we use for distance, speed, and time. Now, we can actually do substitution in this case and then solve, right? So A is S minus 6. How old is she now? We need to find what A is, okay? So what we will do here is, anyway, we can work for Sam first, but another alternative will be, let's substitute first, right? So we'll sub 1 in 2. So A is S minus 6, I'm substituting here. We get S minus 6 minus 18 equals to 2/3 of S minus 18. Is that clear to you? So that means S minus 24, I mean this is S. And we'll cross multiply. We'll multiply this by 3 and we'll keep 2 there. 2 times S minus 18. Clear? Open the bracket. So we get 3S minus, multiply 3 by 24. 3 times 4 is 12 to 172. 2S minus 36. Bring S's together. So we have 3S minus 2S equals to 72 minus 36. So we get S equals to 36. Clear? So we get Sam's age as 36. So what is Anita's age? So we know Sam's age, we'll call this as equation 3. And now we are moving from here to this side. And we know Anita is S minus 6, so which is 36 minus 6, which is 30 years, right? Therefore, Anita's age is 30 years. Is that clear? So that is how we are going to solve it. I hope you find this interesting and useful. So within some time, we have solved 10 questions based on linear systems. Now all these questions were from a test paper. So I hope you're going through this and sincerely working towards it will definitely help you to understand the topic and get good marks. Now I have almost 100 questions on this linear systems. So I'd like you to go through some of these playlists and especially work with the word problems. I have not taken a word problem related to mixture and interest in this case, which are also included. So you should watch some more word problems based on mixtures. With that recommendation, we come to an end of this test paper. Feel free to write your comment, share your views, and if you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.